Good morning, grade 12. Today's lesson is about the sum of infinity and convergence. Now, what does that mean? Sum of infinity means you add an infinite number of terms and you can either get an answer or not get an answer. So if this sum of infinite number of terms has an answer, it converges. That means it goes nearer and nearer and nearer to a certain value or a certain answer, so that you can say, okay, this answer is 7 or 8 or 5 or whatever. And when can a series converge? It can only converge if R, now remember, R is from a geometrical series, not arithmetic. If R lies between 1 and -1. In other words, R must be a fraction between -1 and 1. Only then can you say that a series converges. And we have a certain formula to determine what the answer will be, only if R lies between those two values. And the formula is A over 1 minus R. So let's look at our first example. Let's say we have a series 4 plus 2 plus 1 plus, and it goes on. We first have to determine whether it is a geometrical or arithmetic series. In this case, it is geometrical, because if you say 2 divided by 4, you will get a half. And if you say 1 divided by 2, you will get a half. So we are definitely talking about R. And R will be a half. Let's quickly look at, if we summarize only the first term, so what's the sum of the first term? It will be 4. If we summarize two terms, 4 plus 2, we will have 6. The sum of 3 terms, so it's 6 plus 1 is 7. What will the other terms be if we have to summarize them? So, how do we get from this term to the next term if we know R is a half? Remember, we're working with a geometrical series, so we have to multiply each term with R. 1 times a half will give you a half. A half times a half will give you a quarter. A quarter plus times a half will give you an eighth. And we can carry on like that. So, the sum of 4 terms will give me 7 plus a half. And we will get 7 and a half. And you carry on like that. Let me quickly give you the answers. 7,75, 7,875, 7,9375, 7,96875. And what can you see? That we are going closer and closer and closer to the number 8. We will get closer and closer and closer to 8. So this series definitely converges because it goes closer to a certain value. And therefore, the sum of infinite number of terms definitely exists. Why can we say that? We look at r. R is a fraction, and r lies between 1 and -1. And because r lies between those two values, the sum of infinity definitely exists and we get an answer. Let me show you how it will look on a graph. We said that the sum of one term is 4. The sum of two terms equals 6. 3 terms will be 7. 4 terms is 7.5. 5 terms is 7,75. And you will see it goes closer and closer and closer to the 8 line, but it will never reach 8. Although we said that it converges to 8. So this 8 is almost like an asymptote. If we look at a next example, in this case we have a series of 2 plus 4 plus 8 plus 16, and the terms go up and up and up and up. Again we have a geometrical series, because 4 divided by 2 is 2, 8 divided by 4 is 2, and 16 divided by 8 is 2. So in this case we also have an r of 2. What will the sum of the first term be? It will be 2. If you summarize 2 terms, we'll get 6. Add 3 terms, 6 plus 8 is 14. Add 4 terms, 14 plus 16 is 30. What can you see? The sum of all the terms, if you add another one, will grow bigger and bigger and bigger and bigger. So we won't get a final answer because it will just grow into infinity. Therefore, it will become bigger and bigger and bigger. It does not converge. And therefore, the sum of infinity doesn't exist. We could also have looked at r. Does r lie between 1 and -1? No. Only if r is between those two values, you will get an answer for the sum of infinity. In this case, r lies outside that range, so we can't get the sum of infinity. What happens if we work with an arithmetic series? Let's see. 3 minus 1 is 2. 5 minus 3 is 2. 7 minus 5 is 2. In this case, we're working with a constant difference, d. d is 2. The sum of one term is 1. The sum of two terms is 4. The sum of 3 terms is 9. And 4 terms is 16. Again, the answers will grow bigger and bigger and bigger. So this sum of infinity does not exist, and therefore it does not converge. And if you look at the constant difference, remember, a series only converges if r lies between those two values. We don't have an r, so no convergence, and we can't get the sum of infinity. I'm now going to explain example 1 on page 29, all 3 examples. In the first example, they want us to calculate the sum of infinity for this series. Now first we need to determine whether it's a geometrical or arithmetic series. In this case, it's a geometrical series and we need to work out r. R will be 2 divided by 4 and that will give us a half. 1 divided by 2 will also give you a half. So r is definitely a half. Does r lie between 1 and -1? Yes. So we can use the sum of infinities formula to calculate this series answer. Sum of infinity will be a over 1 minus r. A is still our first term, it's 4. Divide by 1 minus a half. And 4 divided by a half will give you 8. The next question, they ask us to convert 1 comma repetitive 2 to a common fraction. So 1 comma 2 with a dot on the 2 actually means the number is 1 comma 2, 2, 2, 2, 2, 2, 2, 2, 2, and it goes on into infinity. And we can rewrite that as a series. We start with a 1. We add 1 with this digit, and this digit represents 2 tenths. This digit represents 2 hundredths. This one is 2 thousandths. And we carry on. 10,000. When you look at this part of our series, only that part, we also determine that it's a geometrical series. Therefore, we have to work out r. Now, if you divide 2 hundredths by 2 tenths, you will get that r is a tenth. And does r lie between 1 and -1? Yes. Because r lies between those two values, we can use the sum of infinity formula. Therefore, this one stays there, and we treat this part of the sum as a geometrical series. So that part we are going to do the sum of infinity. It will be 1 plus a over 1 minus r. It's 1 plus. In this case, a is not the 1. A is the first term of our series. So it's 2 over 10. Divide by 1 minus r is 1 over 10. And if you type that into your calculator, you will get an answer of 1 and 2 ninths. Therefore, 1 comma 2 repetitive will be 1 and 2 ninths. We also know that this is a rational number. Now go back to grade 8 and 9. Rational numbers are numbers that can be written as fractions, and we just did that. The last example, we have a series, and they ask us for which values of x will this series converge. Now we know that a series will only converge if r lies between 1 and -1. So we need to work out R. R will be term 1 or term 2 divided by term 1. So term 2 is x plus 1 squared divided by x plus 1. Just to be clear, we can rewrite that as two brackets. X plus 1, x plus 1 over x plus 1. Two brackets cancel out and we get that R equals x plus 1. But what do we know about R? R must lie between those two numbers. So -1 and 1 are our bottom and top range. R is x plus 1. We want to get x alone because I want us to get the values of x so that this series converges. In order to get x alone, we need to take this plus 1 to both sides of the backies. Here we get -1, -1, smaller than x, smaller than 1, -1. -1 minus 1 will give you -2, and 1 minus 1 is 0. Therefore, for this series to converge, x must lie between -2 and 0.